Well, folks, got another one for you. Made another micro mill. It's real similar to the one I made before. See if we can raise and lower this so you can see. This one's a little different. It has a 500 watt, 12 to 48 volt spindle motor with a ER16 collet on it. Suitable for wood, plastic, or aluminum. As you can see, there is a metal frame behind here. Goes up all the way around and attached to the top of the column to provide stiffness. I would suggest somebody build something like this. They put a piece of plywood in here or drill a couple holes and fasten it to a wall. So it increases the stiffness. Got a homemade metal vise on here. Homemade XY table. I increased the stiffness slightly by adding this block on the back, but it still needs to be as stiff as possible, so bracing this in the back would be helpful. You've got a power switch here, if I can show that. There we go. Red indicates on. It's got a 36 volt, 650 watt DC power supply, AC to DC. It has a clockwise, counterclockwise switch on it. And it has a potentiometer with an on-off switch, and then the percentage indicator comes on. I pre-marked this for on-off, of course. 900 RPM. 2700 RPM, 4000 RPM, and 5800 RPM. And it's at 78% power. Let's give it a try here and see what it's like on wood. Get this up a little higher so you can see it a little better. It's all tuned in nice and straight. That was about a 15th, 20 thousandths cut in the wood. Of course, with wood, it can go much deeper than that. Next, we're going to try it with plastic. You've got your coarse height adjustment here. Raise the whole head up and down. And then you have a lock for the fine adjustment, which is up here. So you lock it in with the coarse adjustment and then set your height or your depth of cut and lock it in with your fine adjustment. So let's see how it works on plastic. Again, we're going to run it at about 4000 RPM. And there's your cut in plastic. Piece of acrylic. Next thing we'll try is a piece of aluminum. And here we go. Undo this a little bit. And there's our cut in aluminum. Pretty deep cut for that size machine. As you can see, I've been experimenting with it. So, all in all, I think it came out rather nicely. I do have a pallet for it, for clamping down larger items. Again, it's a 500 watt motor, 36 volt power supply, forward, reverse, or clockwise, counterclockwise switch. Shows the percentage of speed or electricity you got going through there, DC power. Nice little machine. Well, if you're ever planning on making one of these, hope it gave you some ideas. Y'all have a good day. Oh, one thing I forgot to mention. The dovetails on the cross slide on the bottom. They're aluminum. I always used to cut them on a bandsaw and then mill them. And then I found out, well, I knew this before, but I found it was much easier to make the dovetails on a table saw. Set the blade at 30 degrees and make very light cuts. Keep raising the blade, keep running the aluminum over it. Carbide blade. If you have a carbide finish blade, that works best. And it's a fast, safe, accurate way of making 30-degree dovetails. The top, of course, is rails and bearings, but the bottom is out of aluminum, and it works quite well, as you can see. And it's nice and stable and rigid, and it operates smoothly. And it has a steel gib strip to bring it into tightness with adjustments. Did the adjustments on the back side or the right side. So, lots of ways of making them. You choose your own method, but it makes for a nice little mini mill. Y'all have yourself a good day. Bye.